Let's talk about a Unijunction transistor. It's got one PN junction. Now the base material is N and this emitter material is P. Current flows from base 2 to base 1. When you forward bias this emitter, they could have picked better names there. Now it's similar to a JFET, and a JFET has one junction, N material and P material. They're doped a little bit differently. And if you reverse bias the gate, it actually turns off the this JFET. Now, in order to forward bias the emitter here, we need to put some voltage on there, and to find that voltage, we take the intrinsic standoff ratio. Now, it has a Greek letter eta, and it looks like an N here. Now, it's the ratio between this B1 resistance here and the total resistance across the unit. And that's usually about 0.5 to 0.8. So, in order to forward bias this, we need to take this 0.5 or 0.8 times the total voltage across the unit, and then we have to add the voltage drop across the diode, say 0.7 volts. So here's the formula here. When the voltage is greater than that, this unit will turn on. So over here I have a little test rig set up. I picked a 10K and a 100 microfarad capacitor. This time constant is going to give me about a 1 second time delay here. So in about 1 second, this capacitor will charge up, and the voltage will increase enough to forward bias the emitter here. When that happens, it'll conduct, this thing will start to conduct, and the capacitor will discharge. Now, in a second later, the capacitor will charge back up again, and it'll keep going around and around. So this thing should flash every second, and that's going to tell us that this unit's working. Now, I wanted to make a little more practical circuit here, so I added an SCR and I added a load to it. An SCR needs a little bit more load than the, say, one LED will provide for it. And I needed to step the voltage up to about 12 volts for the SCR to trigger. Now, I didn't do it on this one, but if you want to, say, have a 10-second time delay on a switch here, you could use a 4K7 and a 220 microfarad capacitor. Right now we're still at 1 second. So when I turn the switch on, 1 second later, this load should turn on here. So we'll give it a try. There's the unit there. Now, it's flashing in about every second. Now, I have it at 8 volts or so. I'm putting a pulse into the gate of the SCR. Now, these SCRs, when they get a large enough pulse on the gate here, it'll turn on, and it'll just stay on. You could remove this pulse after it's on. It'll stay on. It'll stay on as long as you have until you remove the load, or the power to the load here, or if you stop putting power to the pulses to the base, or the base here, and you can short out from cathode to anode here to turn it off. But once one pulse comes in, it's going to turn on. So I'll turn it up to 12 volts, and there you go. Now, once it's on, I can crank the voltage back down. It's not going to turn off until I take the load off of it. There we go. So, that's a Unijunction transistor.